Welcome to this mini tutorial here to show you how to bind a user input, like a MIDI input, to make something interesting happen in a space. And so this is important. So let's say you want to set up a space, you want to set up a world where I can push different buttons on my keyboard, or maybe I have a MIDI controller, like an actual like piano, like a MIDI piano, or I have one of those like pad boards or something kind of like something like that, and we want it so that we can assign every time I hit this particular pad, it does something in the space. Maybe it changes this parameter, maybe it changes a camera angle, or it enables this or does that. How do we do that? And so to understand this, there's actually a lot of different ways we can achieve this, but I'm going to show you a very straightforward way to do this, and then I'll show you then a more global way to do this a little bit later. So one way we can do this is, let's say I have this box, and I want to basically make this into a little user controllable box, something that we can kind of push a button to make it do something. So how do we do that? I created this box, and then I'm going to go to the property editor, and I'm going to click this little button next to box entity and click on player controller. So when we do this, this box entity now has this new property called player controller, and you can think of this as this is how we add inputs to something, like user inputs. So i.e. the user pushes a button on their physical devices and it causes something interesting to happen, in this case to this particular object. So to actually create the input, I clicked on the player controller that was added, then I expanded this item, player controller controls, and I'm going to hit this little plus button here. And here we can click 3 different types of user inputs. Analog user input is for 2-dimensional inputs. So you can think of this as like your thumbsticks, right? Those are 2-dimensional. And so anytime you have that kind of input, you'd want to use an analog user input. A continuous button user input is for any button really, but it's primarily used for buttons like triggers that have values that go from 0 to 1. So in other words, the more I hold down the button, the bigger the value gets, and when I let go, it goes back to 0. So this is for inputs. A lot of times gamepads on the triggers will have values that go from 0 to 1. Also the VR controllers, the triggers have this. They don't just tell you yes, on or off. They tell you a value that goes from 0 to 1. The more you squeeze, the higher that value goes. And so that's really nice when you have that. And also it's continuous because you get notification every frame. So as I'm holding down that button, that my script that I'm going to add to this is going to get called every frame. And then on-off button, which is what we'll do right now, is just simply you get notified when you push a button, like I push A on my keyboard, and you're notified when you push it down, and then you're also notified when you're released. And that means you can call script when you push and when you release. And so that's what we'll do today. And so you can imagine, every time I strike a key on my keyboard, on my piano, or my pad, I would get notified when I push down, and I get notified when I let go. So in this case, we're just gonna I'm gonna assign this. I'm gonna call this jump. That's the name of this control. So in other words, I'm gonna create a function basically that when I hit a button, I'm gonna make this cube jump in the air. And so after we give this, we call this in this case jump, and then after you give it a name, you want to set a default binding. And so what's going to happen is when I click this, it's going to say press a control. Now this can be a VR button on your VR controls, it could be a keyboard button, it could be a mouse button, it could be a button on your MIDI controller. It's basically listening in on all your inputs and waiting for you to hit a control. So I'm going to just, in this case, since I don't have any MIDI boards hooked up right now, I'm just going to set this up to just the letter A on my keyboard. So when I push A, that's the default binding for this control. Now this binding can get a little confusing because there's another way we can set the bindings. So let me explain this a little bit to make this a little bit clearer. The default binding is the default that would be assigned to this. So for instance, I can take this show right now and I can export it to an exe and send it to my friend, or share it on Steam to a friend. They'll open it up, and then by default it will assume that they want the letter A as the default binding to make this cube jump. However, some people have their own configurations for controls. And so what people can do is actually override that default by going under Edit Preferences. And here it lists all your input sets. In this case, this is the player controller we just created. We didn't give it a very good name, so it's just called Player Controller Controls. But you'll notice that jump appears here. So it's here that now the user can say, oh, A, I don't want A. That was the default that was bound. I'm going to override that to something else. And let me actually show you really quickly. I'm going to export this as an application so we can see exactly where that lies in the exported application. So let's say I made my game, and it's this cube here, and I exported that as an exe. I'm just going to open that exe here. This is what I just exported. And you'll see in here I can go configure inputs, and it's in here. You'll see the player controls live here. Jump A is the default. I can now override that. No, I want D to make it jump in my little game here, and that's the idea behind that. So that's why when you click on the player controller, you have this default binding. That's that initial serving suggestion for the user, and then people can override that by going to Edit Preferences and then setting it here. So just be aware of that dichotomy. Because sometimes you might have, if you already have something called Player Controller Controls that you've already bound in the past, it will use these bindings, not the default one, if you've already overridden them. So just be aware of that. So we're popping the stack. We're going back to where we left off. Okay, so we've just added jump here, and we've default binded it to A, and then you'll see that it creates an event called onJump, and so that's the same name as what we've typed in. So I'm going to click on that event, and now we can write some script to occur every time I hit this button. And so notice that this on-off input event passes in this B value. So this B value is true when we push on it, and it turns to false when we release the button. So we're only interested in when we push down. So I'm going to say if B value, this is just an easy way to check to see if that's equal to true, or we could say if B value is equal to true, that's the same thing. And we're going to do something interesting. In this case, the prototypical example that I like to always use is to just make the object hop, like using its rigid body. So I'm going to do self::get rigid body. That returns this object here. So self is the box entity itself. It's going to return this rigid body here, and the rigid body has all these additional properties related to its physical properties. So I'm just going to say apply a central impulse, and I'm just going to type in a guess here as to like how strong that should be. Maybe a little weaker here, 0.5. So every time I hit a button and it's true, I'm holding it down, and when I push it down the first time, it'll call this code. So let's see what happens when I hit play. There we go. Hit A, and it's true. And if I hit A really fast, I can make it fly, keep it up in the air. So we can keep adding additional controls. Maybe we can have it like go in one direction when I hit another button. So I'm going to add another control here, and on when I push it down. Well, actually, let's do a continuous instead. Yeah, let's do a continuous instead. So this is a different version. On continuous button user input, I'm going to give this name. I'll give this like propulsion. So this is like fly, let's say. So A kind of lifts us, and then this will make us fly in its direction it's looking at. So we'll have a look at direction for this. So I'm going to say when I hit S, I'm going to have it fly in this case. So I'm going to implement the onFly. I'm just going to. So notice that this passes in a value. So this value is from 0 to 1. So as we're holding down the button, in this case, since I assigned it to a keyboard button, it's literally just going to be 0 or 1. As I'm holding down the key, it's going to just keep getting called with the value 1, 1, 1, 1, 1, 1 every frame. And then when I let go, it will get called with the value 0 once, and then it stops getting called until I hold it down again. If you had an actual button that supported a nice smooth value that goes from 0 to 1, this would end up getting that value. Would get passed in. So this is a good way to scale like your animations and stuff. Like if the more you hold down, maybe the faster it flies. So you can scale your speed based on this, and that's actually what we'll do here. So I'm going to say self::get rigid body, apply a central impulse, and I'm going to use my get world look at direction. This is the direction this thing's facing. So as it gets rotated, it'll always kind of move in that direction. And since this is a normal, this always has a magnitude of 1, means the impulse will always have a fixed kind of force. We're going to just multiply that by our value. So the more I squeeze, in this case, as it saturates to 1, it'll go to like full strength, and the more I let go, it'll move slower. So let's see what happens when we do this. So I hit play. So I'm going to make it hop, and then apply central impulse. Did misspell that. Okay, so back to this. Play, raise, and then that's super fast. So I'm gonna go ahead and slow that down. So back to the script. So instead, since this is 1 times, in theory, we should factor in the actual like speed of the frame rate. So the problem is that this is not going to scale with my frame rate. If my frame rate is 200 frames a second, since this gets called every frame, this is actually going to apply an impulse, which is an instantaneous velocity that's added to the object in an instantaneous amount of time. It's going to add that 200 times a second. If my frame rate is 10 frames a second, it's going to add it 10 times a second. So it's a value that's going to scale with my frame rate, which is no good. So I've done this in a previous lesson, but I'm going to show you very quickly. I'm going to get my parent space. I'm going to get my timeline for my parent space. And then the timeline has a function called get time elapsed since last tick. And that's going to return a time value that's going to measure. It's basically a measured time value that represents the time that from last frame to this frame. And now we can scale our impulses based on this. So I'm going to convert this to seconds. So our impulse is equal to the amount of time elapsed between 2 frames times our f value. And so now by using that instead, this will be nicely scaled based on the amount of. This will be the same regardless of what our frame rate is. This may still be too fast. So let's see what happens. Hit play, and that is not the function. I always forget the name of these functions. So I'm just going to go ahead and look up the timeline. I'm going to go to the timeline. Get time elapsed from last tick, not since last tick, from last tick. Hit play. So that raises it, and notice that it's much slower now, and it always moves in the direction that. So now it's looking down the cube. You can imagine. I'm going to go ahead and edit local space here, so we can draw a face for it. Edit local space, and I'm just going to go around here. We'll add a sphere that represents its space. This is its face, basically. It's looking in this direction. And then I'm going to go back out, and so now you'll see that it always moves in the direction of the sphere. Ugh. This is a very, very weird game. So I'm going to speed that up a little bit. So I'm going to scale this. Now we can safely scale this, maybe times 4. And now this should be, there we go. Keep that in the air, and then have it fly over there. And then have it fly. I'm going to actually add camera tracking to this. So I'm going to hit camera. And I'm going to say tracking player controller. This will track whatever object is set as the player controller, which, by the way, this is another thing I need to explain. So this object has a player controller, but now what if I created another object in this space that has a player controller? So for instance, I'm going to go to actors here. I'm going to create a movable ball. So this is also an object that has a player controller on it. It's actually on the actor object, but it also has a player controller. So notice if I hit play now, it's actually the sphere which is active now. Now hitting A does not cause this thing to jump anymore. So why is that? Why does that work that way? Well, the main idea is you can only have one active player, one active player controller per space, a node of a player controller. And so how do you define that? So you can just right-click on an object and you can set as viewport player node. So what's actually happening is it's the viewport itself. If we click on the viewport here, you'll see it has this property called player node. That's what determines where the input is getting dispatched. And so when I drew this sphere, it automatically assigned it to be this as the active player controller. I can override that by right-clicking on this and going back to this. Now this is the active player controller by setting that. And again, by calling, when I use this set as viewport player node, it's just going into the active viewport, which is this, and setting this player node to be this. So now it's set to this object. So now this object is controllable since it has a player controller on it. Or I can go and set it to this, and now that property's been set to that. And so that's how we determine if we have multiple objects with player controllers, which one's currently active. So I'm going to set it back to this thing. So I hit play. And so that's an important thing to understand, is that this is really weird. And so the camera tracking that I added will track whatever the current player node is, which in this case is this object here. If it was a sphere, it would be that object. So this is pretty weird. So again, this could be our MIDI input, and this could be just about anything we want. Now, another thing you might want to do is, let's say I don't want to have to necessarily create an object in the space that is going to act as my input dispatch. Maybe I want to just create global buttons that have no connection to any objects in the space that when I push will be active. And so you can do that by clicking on the ground, notice, and clicking on the terrain space. So the space in this case is everything in this world, everything in this space. And we can actually attach a player controller directly to that terrain space in this case. So now these inputs are always active. So long as this viewport is rendering, so long as this space is active, these inputs will always be active. And so here we can create global buttons. So I'm going to create a new on-off, and I'm going to call this like nighttime. So when I push this button, it's going to switch this world to nighttime. And I'm going to make W go to nighttime. And so on nighttime, I'm just going to take the terrain. I'm going to click on the sky here. I'm going to set the sky space night sky to true. So I'm just going to drag and drop this into here. So whenever I hit on nighttime, we're going to set, night sky to, actually we're going to set it equal to V value. So it's going to be true as I'm holding it down, and when I let go, it's going to go back to false, which will go back to daytime. So now, because this space has a player controller on it, this player controller will also be active. So now the space will have this thing active, that's determined by this player node that's set for the viewport, and then the viewport will also have this player controller on the space active. So the space is able to have a player controller active, and that's always active, in addition to the node that's defined by that viewport property. So now let's see what happens when you play. And now I hold down W and we're in nighttime, and I let go of the key, it goes back to daytime. So we can actually put a light source on here. Maybe this orb here is actually a light source. So I'm going to go and edit its local space. And then I'm going to create a light source. And I'm going to make that a point light. I'm just going to stick this in the middle of this thing. And I'm going to make that it's a point light. So actually it's going to cast a shadow on itself in this case. So maybe we can just stick it in the middle of this. And then maybe we'll make the sphere not cast a shadow. So now we can't see it during the light in the daytime, but at night it should work. So I'm going to hit play, and I'm going to go to nighttime, and now we have this interesting shadow here. Maybe I can fly this to that sphere. Actually, let's create a little like space around this object here. So I'm going to create a bunch of boxes here. This is like our weird. I'm going to have to make these not movable actually. So let me just do this first. I'm going to make these not movable. Select them all. Rigid body movable false. Hit play. Go to nighttime. Fly this thing around. This is actually really hard to hold down that button while I fly this. And there we go. This weird spacecraft thing. So we have this global button that's always active, W, that I can hit at any moment. That's not associated with any particular object in space. And then I have this other thing. These two buttons are controlling this in particular. So now if I wanted to, for instance, switch to this programmatically, let's say if I fly this thing through a trigger, I'm going to create a trigger here. This plane trigger, I'm going to just draw this here. Let's say when I fly through here, it activates this sphere, for instance. So I'm just going to go double click on that trigger, on enter. I'm going to just set the viewport. That property is what we want to set programmatically, right? Player node. I'm just going to drag and drop that viewport in here. I'm going to say this thing's player node is equal to, in this case we want to set it to the sphere. So I just found it here. Movable ball is what we want to set it to. So I'm going to drag and drop that in there. So now when I fly this thing through this trigger, it's going to make the sphere active as a player object in this space, and then this will deactivate. Basically, this thing will just drop out of the sky. So I play. This thing's currently activated. It's going to be impossible for me to do it. There we go. So now I fly through that, and then now the sphere is activated. So now I can roll the sphere down. And the camera tracking updates to this because that became the player node of the viewport. And as always, W works to make nighttime here. So let's say, again, back to the MIDI kind of domain. Let's say I take this world and I export this as an application. We call this test2. And now let's say this is my VJ set. This is a very weird VJ set, but let's say we had that. We go to test2. This is what I just exported, and I open this up. And let's say I have my own MIDI board with my own controls. I would go to configure inputs. I would select, in this case, the movable object is our sphere, and our player controller, this is that weird like flying thing with the nighttime lives there as well. I can go and assign these, since unfortunately I didn't give the spaces nighttime, like that global player controller, a different name. It merged them into one here, but I can set nighttime to my MIDI boards, like keyboard button. I would just do that in here. I would say set. I'm going to actually bind this to Q instead, and now in this world, Q goes to nighttime. And my little game here, with my sphere being activated, and Q goes to nighttime. So another thing to be aware of is the BPM controls. So the BPM controls, for instance, let's go ahead and add those. Live tools, BPM controls. When we create the BPM controls here, which are added to an overlay viewport, but I'm not sure why I didn't add them here. That's very mysterious. Why didn't it add that space? Okay, let's pretend like that didn't happen. Let me try that one more time, since just for my own curiosity here. Live tools, BPM controls. I'll have to look into that. For some odd reason, it is not adding it. So it creates the space here that have the BPM controls. It should be adding it automatically to this overlay viewport. I don't know why it's not doing that here. It's a bug. It should do it for you automatically, but I need to verify. There's something about this space or some change I've made that's causing that not to happen. But anyway, okay, you go to Live Tools. Let's pretend like that didn't happen. You go to Live Tools. You click on BPM controls. You add it to the space. That adds this thing here. And so you'll notice that here when I hit play and I tap, and just like I showed in a previous example, it does these kind of live controls like this. And I think I've added multiple ones since I recreated a bunch of times. So there's a bunch here now. I'm going to delete one of these. The other thing that you'll notice is that this has a, if you click on the root node, it actually has on this BJ control screen, if you click on the control somewhere here, oh, right, you'll see that this has a player controller by default. So you notice that tap beat, resync, auto, double BPM has already been added. So long story short, when you create these live tools, you'll be able to go under Edit Preferences, and you'll see these VJ controls. And here you can actually map these to inputs. In this case, I have tap beat set to number 1 on my keyboard, 2, and so forth. So now if I hit play and I hit 1, that's also the equivalent of hitting tap. And resync and auto and times 2 and divided by 2. So I'm going to do File New, just do this from a fresh example here. I'm going to go to Live Tools, add a BPM control. Why did that not? Sorry, folks, I made some changes very recently that may have broken this. I need to look into this, but if you do that, that's really strange. It adds the controls. Just make sure you add that screen to that overlay viewport. I'm going to be fixing this in like 10 minutes. There'll be another update going up. That should be added automatically. Hit play, hit tap. Those controls are added. Hit number 1 through 5 to map to those. And so there we go. So that's another way of thinking of. That's how you can connect inputs to the control buttons in this case. It's also through a player controller. Again, if I created a big old button here and I wanted to assign a button that I can then push on my keyboard or whatever on my MIDI controller, I would just go here and create a new player controller. And then in this player controller, I'm going to create a new input, on-off button. And then in here, I then hit a button and then make this glow or do something interesting from within there. So that wraps up this example. Happy to keep kind of exploring other ideas. This live control thing issue I will be fixing in like the next 10 minutes. So yeah, hit us up in the Discord channel if you have any other questions. Thanks for watching.